All right, welcome. In this video, we are going to be looking at some higher level polynomials. So that's really focusing on x cubed and up. And we're going to be looking at three main features of these polynomials. We're going to take a look at the end behavior, which we have discussed previously for other functions. We're going to talk about the extrema. And then finally, we are going to talk about the zeros of these polynomials. Zero is just another word for x-intercepts, or maybe you've heard it as roots before. But we're going to examine each of these features. So to start off, end behavior, right? What is a polynomial going to look like on a graph? Well, a polynomial is going to have some number of terms. It has all these extrema, and then its domain really is going to be negative infinity to infinity, all real numbers. So the question is, well, what is happening at the left end and the right end of the function? So if we recall, our left end behavior is given as the limit of f of x as x approaches negative infinity, right? That's our left end behavior. And then our right end behavior, I'm going to put it down over on the right side. Our right end behavior is just, well, what's happening as we go to the right side of the graph. All right, so our right end behavior is our limit of f of x as, well, what do we mean when we say go to the right side of the graph? That's as x approaches infinity. All right, so the keys for these is to kind of examine what's going on with x and x squared, because even functions are all going to act the same and odd functions are all going to act the same. All right, so if we have, let's say that we have f of x is equal to x squared. So say we have f of x is equal to x squared, and there could be anything after it. All we really care about is the leading term. So the leading term is the term with the highest degree or the highest exponent. So all we really care about here is the x squared. We know that x squared, well, that's a parabola. And when that x squared is positive, it points up. All right, so if that's a parabola and it has a positive coefficient, it is going to, well, my y value is going to go to infinity both as we go to the left end and as we go to the right end. All right, so for this, well, my limit of f of x as x approaches negative infinity will be infinity because it's pointed up to the left. And then my limit of f of x as x approaches positive infinity is also infinity because we're pointed up as it goes to the right. So for any even degree, okay, if my leading term has an even degree and a positive coefficient, both arrows point up. All right, let's switch it up now. Let's switch it up. Let's take a look. Let's say, what if we have f of x is equal to negative 2x squared plus 6x minus 5. All right, a random function. But now we see it's still an x squared. Well, my leading term tells us if it's an even power, the arrows are going to be pointed in the same direction. In this case, it's multiplied by a negative 2. So guess what? They are both going to point down. So for this, my left end behavior, of course, as x approaches negative infinity, is going to be going to negative infinity because my left arrow goes down. And then my right end behavior is the limit of f of x as x goes to positive infinity. Well, my right arrow is also pointed down, so this is going to negative infinity as well. And again, that's going to be true if our leading term is an even power. So if this was x to the fourth, it would be the same. If it was x to the sixth, it would all look the same as x squared. Okay, it's all going to look the same as x squared at the ends. All right, so those even powers, or our polynomials of even degree, which again just means the first or highest exponent, our highest exponent is even. All right, they will all look the same as x squared. And we'll make a chart to help us in a second. Let's take a look at f of x is equal to just, let's use x to the first, right? If I have x minus 6, I know that this is just a line. Okay, this is going to be the graph of a line with a y-intercept of -6, my slope of 1. Well, when I have an even degree function in a positive coefficient, okay, as x goes to positive infinity, well, my arrow's pointed up, that goes to positive infinity. For my left end behavior, so as x goes to negative infinity, my y value is also pointed down to negative infinity. All right, if we were to make that a negative x minus 6, well, my function will look like this. And then it's just going to switch. So my limit of f of x as x approaches infinity would now be negative infinity. And my limit as x approaches negative infinity of f of x would now be positive infinity. Okay, and that is going to be true for every single polynomial with an odd degree. Okay, again, the green is when the coefficient is positive. Okay, coefficient is positive. The red is when the coefficient is negative. So let's just make a quick chart. Okay, we're going to make a quick chart. So up top, let's use our degree, which again just refers to the highest power. So if the degree is odd and even, and then if that leading coefficient, so the coefficient of the x term with the highest power, that's our leading coefficient, which I'll just call coefficient. All right, if that is positive and if that is negative. All right, and we're going to fill out this chart right here. All right, so if it's positive and it's an odd degree, my arrows are going to be pointed down on the left side and up on the right side. It's down on the left, up on the right. For negative, well, it just switches. Okay, it just switches. Imagine x to the first. Okay, think about f of x equals x, right? That applies for all odd degrees. All right, so if the degree of the function is x to the 11th, well, guess what? As long as it's a positive x to the 11th, as we go to the left, it's going down. As we go to the right, it's going up. And then for even functions, well, let's think of f of x equals x squared. Let's think about what that does. If the coefficient is positive, then both arrows point up. And if the coefficient is negative, both arrows will point down. All right, so this chart maybe you could find to be a little bit handy for you. So doing some example problems, if f of x is equal to negative 3x cubed, well, this is our first term, and it's an odd degree, and it's negative. So as x goes to the left, well, it's not going to go down. It's going to go up now because we have a negative coefficient. And then as x goes to the right, so as x approaches infinity, we're going to go down to negative infinity. So that's going to be a negative infinity there. All right, don't miss that negative sign. I couldn't really fit it, so sorry about that. All right, for this next one, we have positive x to the 4th, so that's going to look the same as positive x squared. Well, lim of f of x as x goes to negative infinity, well, both arrows are going to point up. So that arrow's up. And as we go to the right, that arrow is also pointed up. All right, for this last one, h of x, it's given to us in factored form, which is actually going to be very useful for us as we learn how to graph the zeros. Well, x times 2x times negative x, right? We don't have to worry about foiling this whole thing out. Just multiply the x's together. That's going to give you what your leading term is. So your leading term would be a negative 2x to the 4th. Well, that's going to tell us both arrows point down. So the limit of f of x as x goes to the left, that goes to negative infinity. And same thing as we go to the right. All right, that's also going to go to negative infinity. All right, next up we have the max number of extrema. All right, let's look at the graph of x cubed. The graph of x cubed just looks like this. However, if you start to add some things after x cubed, it could look like this. All right, and in this case, we could have two extrema. For x to the fourth, well, the regular graph of x to the fourth just looks like this. It looks very similar to the parabola, but it also could look like whoop, 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 in which case we see that we have 3 extrema. All right, for an x to the fifth graph, okay, for an x to the fifth graph, yes, it could look very similar to x cubed, or say it had a bunch of stuff after it. It could have the maximum number of turns it could have is it could go 1, 2, 3, 4, 5. All right, so it has 5 extrema and also 5 turns. When I say turns, I'm just talking about it goes from increasing to decreasing or vice versa. So this one, x to the fifth, could have a maximum of 4. Okay, it could have less than that, but it could have a maximum of 4. X to the fourth could have a maximum of 3, and x cubed could have a maximum of 2. What we are going to find is the max number of extrema, or turns, is going to be 1 less than the degree of the polynomial. So for this one, the max turns it could have is 2. For the next one, the max turns it could have is 5. And for this one, the max number of turns it could have is 99. We're just taking 1 less of each of those. Could it have less than 99? Yeah, it definitely could. All right, it could definitely have less than 99, but it can't have more than 99. So if you tried to say that, oh, this function has 100 turns, no, it definitely can't. All right. And lastly, we are going to look at the max number of zeros a function can have. Well, x squared, let's look at, remember that zeros is the same exact thing as x-intercepts. X squared could have 2 of them. It could also have just 1 of them if its vertex lies right on the x-axis. Okay, so this one has 2. The second one has 1. And the last one actually could have 0. Right? We saw some that the vertex is up above the x-axis and it opens up. Well, that one has 0. So the max number of zeros that an n-degree polynomial could have is just the same number as its degree. Okay, so the max number of zeros would be n. It could be less than n, but the most it could have is n. So find the max number of zeros of each function. Well, this first one is to the 5th power, so the max number of zeros it could have is 5. The second one's to the 3rd power. Maximum number of zeros, or x-intercepts, it could have is 3. And the last one is to the 8th power, so the maximum number of zeros it could have is 8. Hope this helps you guys out for the homework, and have a great rest of your day.